Hello, you're welcome to our presentation titled Evaluation of Power Saving Models in Energy Aware Data Center using the GreenCloud Simulator. My name is Cornelius Agbo, and this paper is co-authored with Nathan David and CN Asiegbu. To start with, what is cloud computing? Cloud computing is a model that enables on-demand access to a shared pool of configurable computing resources such as servers, networks, storage, applications, and services. The advantage of cloud computing comes from the fact that, unlike in traditional approaches where you have to build up your own data center, cloud computing allows you to lease the resources that you need, on a pay-per-use basis. So you don't have to build a data center that could be smaller than the capacity you need or too big for the capacity you need. You don't have to spend more money setting up a large data center, which is indeed capital intensive. So cloud computing is good for everyone. It makes life easy, right? So, and there are three popular service models in cloud computing. We have the infrastructure as a service, such as the Amazon Web Service, a good example. And then we have the platform as a service that gives you the platform to deploy your applications. An example is the Google App Engine. Then there's the software as a service. One example is the Microsoft Office that now runs as a software on the cloud platform. So cloud simulators, which is our core area of focus here, are software tools that allow us to simulate an actual cloud computing environment for the purposes of research and experiments. So, for example, before you deploy your operational cloud environment, it is important to study how this cloud you're deploying will perform under different circumstances or under different conditions, load balancing conditions, or you know, and all that. So these cloud simulators allows you to do these experiments before you go into building your actual cloud platform. Because after building your actual platform, you can't find out later that maybe it consumes too much energy and then you demolish it and need to build it. And so this is where cloud simulators come handy. There are many cloud simulators available. Popular examples include the Cloud Sim, GreenCloud, Cloud Analyst. In this paper, we want to demonstrate the use of GreenCloud Simulator in the study of energy consumption in data centers. GreenCloud Simulator actually is an extension of the Network Simulator, the NES2, which is used to evaluate energy costs of data center operations. Its working principle involves measurements of energy consumption by various data center components, such as the links, the servers, and the switches. So by measuring this energy consumed by the various components of the data center, you can calculate the total energy consumed by the data center. So you basically use an energy saving scheme or energy saving mode, such as the dynamic voltage and frequency scaling. And then you compute this energy consumed under this particular energy mode and use different energy modes, and then you measure the total energy consumed. So you can know the optimal power saving scheme to use in the real cloud deployment. So to make this our experiment repeatable, we reproduce here the simulation parameters we've used. So we had 433 computing nodes, 3 core switches, 6 aggregate switches, 3 access switches, and here are the link capacities for the core switch C1 to core switch C2 have 100 gigabytes, C2 to C3 have 10 gigabytes, and C1 to C3 we have 1 gigabyte. So in what follows, in the subsequent slides, I'll be showing you guys the energy consumed under 3 different selected energy saving models. So we have linear energy saving or linear power model, the component power model, and low power model. So here is the linear power model. The total energy consumed under this model is 63 kilowatts. And server energy. So the server consumed 55% of this total energy. That's very important, so pay attention to that. So you will notice in the second energy model, which is the per component power model, that the energy consumed has gone down from 63 kilowatts to 51 kilowatts, and the power energy, the server energy rather, has equally gone down to 45% of this, and not as much as 55% we had in the previous case in the linear energy model. So in the low power model, which is the third power model, so you observe that the total energy has gone down further to 32 kilowatts, and the server energy is nearly 13%, which is quite interesting. So you see that the server energy is only 30% of this 33 kilowatts. So with this energy model, we have been able to reduce the server energy substantially. So here is the table that shows all the results at a glance. So as you can see, the server energy varies substantially from linear power model to the component power model and then to the low power model. And that translates to the total energy consumption from 63 to 51 and then to 32. The access switch and the aggregate switch have constant energy consumption because they are always running, so the different power schemes do not affect them. The switch energy, the core switch equally has fairly constant energy consumption. So yeah, here we further highlight the results from the previous slide, which demonstrates that the server energy is the one that is most variable. The other ones are fairly the same. So if we map these variations in the total energy consumed to the cost, the annual cost of running the data center, we will better appreciate the impact, the significance of this study. So you will realize that taking the assumption that 1 kilowatt hour will cost $0.1 and that there are 8,760 hours in a year. So you will find out that the total cost of running the data center per year is about 55,000 in the case of a linear power model, and this goes down to 44,000 in the component power model. But with low power model, you are spending only 28,000. So the change in cost here, the variation in the cost is very significant, and this leads us to the conclusion that by using the GreenCloud simulator to investigate different energy models or energy saving schemes, we can observe that there are variations in the total energy consumed by these different energy saving schemes, and that these variations in the total energy consumption can easily translate to the cost for running the data center per year. As you can see, the cost can go down from 55,000 to 28,000 if the appropriate power saving scheme is selected. So based on that, GreenCloud simulator affords us the opportunity to select the optimal energy saving scheme that will help us save substantial amount of money in running the data center. Thank you for listening. If you are interested in the references, you can find them here.